Hey there! In this video, you're going to learn how to use functools.partial. You're going to see how you can use it to improve your code. You're going to understand how it works, why you would want to use it, and you'll also learn about the improvements that functools.partial is getting in Python 3.14. So the best way to start is through an example because that will make sure you understand partial. You probably know the built-in int. And if I run the built-in int with the string argument 101, you get 101 back, the integer. So I can add 1 to this, for example. But the built-in int can work in a slightly different way. You can specify a base. So if I say that I want to take the string 101 and turn it to an integer, but using base 2, this is now reading the string as a binary number, and you get 5. And you could do this obviously with other strings. So now if you do 1101 base 2, you get 13. So as you can see, by using the built-in int and by setting the keyword argument base to 2, the built-in int transforms strings in binary to integers. So in other words, if you set base to 2, if you fix that, if you freeze that value in that argument, the function gets a new meaning. Now instead of just saying, okay, I'm turning strings into integers, you're saying I'm interpreting strings as a binary integer. And this is exactly what partial is useful for. So I'm going to go ahead and open this text editor. So from functools import partial. And what partial will allow you to do is to kind of take the built-in int and freeze the 2 as the base keyword argument. That's what partial will allow you to do. And in order to do that, what you need to say is you're going to call partial, you pass it the built-in int, and then you say that base is 2. And this will return a new function, which you can call, for example, from binary. So this is the idea. And now if you call it with the examples you've seen already, from binary of 101 should be 5, and say from binary of 1101 should be 13. So let's run this and make sure we're not saying anything silly. There you go, you get the 5 and the 13. So partial here is taking your built-in int and it's freezing the base as the value 2. So this is what partial does. It allows you to do partial application of the arguments in a function. So you can think of your partial int comma base equals 2 as this thing here, and then partial will let you fill in the remaining spaces. Let's take a quick look at another example. So let's make this larger again, and let's run Python, the Python REPL. So now I'll define a list of fruits with, let's say, apple and pear and banana. And let's give me a second. Yes, so it's up there. Okay, so these are the fruits. Now if you use the built-in max and you pass the list of fruits to the built-in max, what do you get? Strings will be compared by the order of the letters, and so pear is the word that would appear later in a dictionary, right? Because P comes after the A and comes after the B. The P in pear comes after the A in apple and the B in banana, so the max will be pear. However, if you take the max and you pass it a list of fruits and then you say that the key argument should be the built-in len, now max will use the built-in len to compute the lengths of the strings and find the string whose length is largest, which means it's looking for the longest string now, which in this case is banana. And obviously this works across lists of strings. It doesn't have to be a list of fruits. So let's say now we have a list of people's names. Let's do Bernard, and then let's do Anna, just two, for the sake of simplicity. Now if I do the max of people, with the key set to len, you're going to get what string? Is it going to be Bernard, which has like 7 letters, or Anna with 3? Well, you do get Bernard. So what you see is that by taking the built-in max and freezing the keyword argument key to be the built-in len, you're now computing the longest item in your argument list. So you can go ahead and you can create a function with partial that does exactly that. So the idea now is to take the built-in max. Let's scroll this out of view. The built-in max, and it's going to take some list there, but key is always set to len. So that's what partial does. You get partial, you pass it the built-in max, the function whose arguments you want to freeze, and then you set key equals len. And this creates a new function. You can just call it longest, for example. And now if you do print of longest of the list of fruits, apple, pear, and banana, this should give you the string banana. So let's run this and see if everything is all right. And you get the banana at the bottom. So this is what partial does. It allows you to take functions and freeze their arguments. This is the key idea. Now, partial doesn't have to work only with keyword arguments. Partial also works with positional arguments. For example, the built-in range starts counting from 0, right? But if you said range from 1, and now you say partial, and you pass it the built-in range, and you just type 1, the number 1, without any keyword arguments here, what's going to happen is that partial is going to interpret this as range 1, and then more arguments. So if you do something like print the range from 1 and then you pass it a 5, you're going to get a range that starts at 1 and goes up to 5. So if you run this, you get your range from 1 to 5. Or if you turn this into a list, so you can see the numbers, you're going to get the numbers 1 through 4, inclusive. So let's run this. There you go, the numbers 1 through 4, so 1, 2, 3, 4. So partial will accept positional arguments and keyword arguments. Let's get rid of this from functools import partial, and let's see this in action, just a final check. So let's create a very generic function that accepts however many positional arguments you want to pass it and however many keyword arguments you want to pass it. And we're going to print them. We're going to print the arguments and the quarks. And now we're going to use partial to play with this, to see how partial works. So if you do something like, this is our first test, you take the partial, you give it the foo, and then you pass it 1, 2, and 3. You can call test1 without passing any more arguments, and the numbers 1, 2, and 3 will be positional arguments here. So let's say actually positional args. So it's clear what we're doing. Let's do f here, f string keyword args. So we see everything. So calling the function test1, we'll call foo with the numbers 1, 2, and 3 as 3 different positional arguments. Let's run this. Python of partial.py. Here you have it, the positional arguments 1, 2, and 3. Now, if you pass more positional arguments, partial will put them after the ones you already froze. So you will get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then, if you take the partial and you pass it keyword arguments, let's build test2, you can say here hello equals world. When you call your function, you're going to get the positional arguments and then your keyword arguments. So you can run your file now, and this is the second example. You see the 1, the 2, and the 3, and then the hello keyword argument that is the string world. And now let's comment this out so we only have one output on the screen. And now if you pass further keyword arguments, let's say by equals cruel world, what Python will do is it will take this keyword argument by and also pass it into foo. So you will get the 1, 2, and 3 that were frozen, the hello world that was frozen, and the by cruel world that you passed in by hand, right? So just checking, you get the hello world and the by cruel world. Now let's see what happens if you try to overwrite the keyword argument that you froze. So inside partial, you're freezing hello to be world. And when you're calling the function, you're saying that hello should now be cruel world. So let's see what happens. So when you do this, when calling your function, you override or you try to override a keyword argument, you do get the new value. So the frozen value is discarded and you get the one you passed in by hand. So this is how partial works and how partial manipulates your arguments. But there's something that's not great about this. So let me show you a different example. We still want to use partial. And now we want to import a second standard module, which is this module string, that contains a couple of very useful constants, and in particular this string.punctuation is partial.py. This is a string with lots of punctuation signs. And now I'm going to use this to build a function that removes punctuation from strings. Let me show you how this is done. So I'm going to create this variable called table, which I'm going to create by using a string method that's not very well known called makeTrans, as in make translation. And I'm going to pass it two empty strings, because I don't want these two first arguments to do anything. And then I pass in that string with punctuation signs. So this will create a table, a translation table, that wants to remove punctuation symbols from strings. And you put that table in this variable. And then if you have something like a string saying hello, world, ! You can then print it and use the method translate with the table you created before. And this will remove the punctuation from the string hello, world! ! As you can see here. Now, the thing is, you can look at this and you can understand that the behavior of removing punctuation is done by the translate and the table. The s dot is just the string whose punctuation you want to remove. So how would you use partial to freeze the table as an argument to this method? Well, the first thing you gotta do is realize that doing s.translate is the same thing as doing stir.translate and then passing in your string s and your table. So this is the same thing. So let's run it and make sure that the hello world still has no punctuation. All right, it's going well. So now it kind of looks like you want to use partial, so you can get rid of this, and you want partial to do something like stir.translate. The three dots are where your custom string goes, and then you want the table to be fixed. This is your end goal. Now the thing is, because this is the second argument, it's not the first, you can't use positional arguments, because you saw how partial takes your positional arguments and puts them after the ones you froze. So you can't freeze table as a positional argument, so you must freeze it as a keyword argument. Now, you don't know the name of this argument, so you check the documentation to see its name. So you can use the built-in help on the stir.translate method. And here at the top, it shows you the signature of the function. It says that translate takes self, the string you're translating, and then table. So it looks like the argument is called table, but then there's this weird / here. So let's maybe ignore it for now. Let's see if you can use partial to do this. So a function that, let's say, strips punctuation would be the partial of the stir.translate with a table set to the table. Now, will this work? Now you want to call this on your variable s. Let's run it. Apologies, I meant to do this. Python partial.py. And you can see it does not work, because the / that you saw in the stir.translate method means that the arguments to the left of it must be positional only, so keyword arguments do not work. And until Python 3.14, this meant you could not use partial for this scenario at all. But since Python 3.14, you've got this new thing called a placeholder, which I'm going to import as _p, because placeholder is quite a mouthful. And this placeholder lets you freeze positional arguments in situations where you don't want to freeze the first one. So instead of having the ellipses, you can put a placeholder there, and Python will know to fill in that missing spot. So the correct way to do this is not with the table equals underscore table, is by saying that before the underscore table, you need a placeholder. So look at this signature. It's telling you that the stir.translate function will have a placeholder first, which is just a spot for an argument, and then the table. And by running it like this, it should now work. As you can see, hello world. So this is how partial works. There's a couple of small things you might look into if you're interested in seeing how it really works under the hood, because this partial object has a couple of attributes if you want to do introspection, and it essentially just works really well in these scenarios. But why would you use this? And the two main use cases are to create callbacks in places where you need callbacks, like when you're building UIs, for example. Then it makes sense to use partial to freeze arguments. And also in situations like the ones you saw in this video with the from binary, with the longest, and with the strips punctuation, where by using partial, you're building specialized versions of the functions you had originally. So int became from binary, max became longest, and stir.translate became strips punctuation. So these are very good example use cases. And now you're thinking, why would you use this instead of a lambda? Well, partials are better for introspection. So a lambda is a very opaque object that doesn't really let you peek into it. There's not much you can see after you build the lambda. It's very difficult to get information out of it. But with partial, you can still see what was the original function, what are the positional arguments that are frozen, what are the keyword arguments that are frozen. By using partial, the semantic meaning of your code is also clearer, because partial says, I want to freeze arguments. A lambda could be something else. You need to read the full lambda to see what's going on. And also, when your functions have long signatures, a lambda only works if you recreate the full signature. So you end up having a really long lambda, whereas with partial, you can just specify the bits that you want to freeze. So partial is also more ergonomic. It's more convenient to use. So I would say that these are the most important things to know about partial and about placeholder, which is coming in Python 3.14. So if you enjoy this and if you want to learn more about Python, feel free to subscribe. I'll also share a couple of links below if you want to see more examples of partial being used to create specialized functions. And yeah, subscribe to stay updated. Bye.